Hello and welcome. I'm Saeed from storyplanet.net. Dive right into the essence of the most captivating books without reading them cover to cover. Whether you're on the go, at the gym, or just relaxing at home, we offer you a unique and enriching listening experience. Today, we are exploring the book, The Male Brain, a creation by Louann Brizendine. The Male Brain, 2010, delves into how hormones and brain development influence the growth of male brains and behavior, connecting neurobiology to masculine stereotypes and proposing that hormones sculpt the male brain and perspective across a lifetime. Before we delve into these revelations, it's interesting to note that Louann Brizendine, an American neuroscientist, researcher, professor, and clinician, authored 3 books, including The Female Brain, which inspired the 2017 film of the same name. With 7 key ideas to unveil, brace yourself for a deep dive into this captivating book on storyplanet.net. To start, the text explores how hormones impact the development of male brains and behavior. First 8 weeks of life, all brains appear female. At around 8 weeks, male embryos receive testosterone surge, triggering male brain and body growth. Hormones influence growth, behavior, and bonding throughout life. A neuroscientist's research can explain male behavior. Key idea number 1. This text likely discusses information related to the development of the male brain, possibly emphasizing distinctions between male and female brains. From 8 weeks of gestation, 3 hormones significantly impact male brain development: testosterone, vasopressin, and Mo1-foluorine inhibiting substance. These hormones shape male behaviors, brain circuits, and responses to threats. Male brains differ anatomically from females, showing increased amygdala size and fewer communication connections. High hormone levels in infancy affect emotional recognition and behavior, making males less responsive to danger cues and more prone to exploration and aggression. By the first year, hormone levels decrease but leave a lasting impact on brain development, shaping male tendencies and behaviors in childhood and beyond. Key idea number 2. The text discusses changes in the adolescent brain during puberty, specifically how it can impact decision-making and emotional control. It highlights the importance of understanding these developments to better support teenagers during this crucial stage of life. During boyhood, male brains exhibit distinct characteristics from female brains, leading to differences in play styles and behaviors. Boys focus on physical activities like racing and rough play due to more structures for muscular control, spatial awareness, and hierarchy. Winning satisfies their need for challenges and triggers dopamine release. Testosterone influences behaviors like an interest in playing with their genitals. In puberty, testosterone levels increase, leading to physical changes like acne and body hair, as well as intensified aggression, challenges with authority, and a drastic need for independence. Teen boys may appear moody, uncommunicative, and rebellious, driven by hormonal changes. These shifts affect decision-making with a focus on action, challenges, and risks rather than communication. The prefrontal cortex, responsible for understanding consequences, is still developing in teens, leading to a lack of impulse control. Testosterone also influences sexual drive, leaving a long-lasting impact on male brains. Key idea number 3. The text discusses the relationship between sexuality and male brain function. Testosterone drives the sexuality reward system in males, with the hypothalamus playing a key role in triggering puberty and mate-seeking behavior. Vasopressin, the male bonding hormone, complements testosterone by promoting intimate relationship bonds through physical contact. The male brain shifts from mate-pursuing mode to mated mind, influenced by vasopressin, dopamine, and hormonal receptors. This can lead to monogamous behavior in some males, while others with low vasopressin levels may remain in mate pursuit mode. The interplay of hormones and brain circuits shapes male behaviors, with vasopressin sensitivity affecting bonding and transitioning to a mated or dad brain. Key idea number 4. The text likely discusses the differences between maternal and paternal brains and how they are shaped by parenthood. It may delve into the hormonal, structural, and behavioral changes that occur in mothers and fathers as they become parents, highlighting how these changes impact parental caregiving and bonding with their children. When a male brain in mate pursuit mode meets a mate, dopamine is released, causing pleasure. Testosterone and vasopressin drive sex and bonding behaviors. Separation results in anticipation and obsession for the next encounter. Male brains continue to seek other potential mates, even with pair bonds. Hormones lead to mate-guarding behaviors and heightened emotional responses. Becoming a father leads to increased vasopressin and bonding with the child. Testosterone levels drop during pregnancy, preparing the brain for fatherhood. Active involvement of fathers in pregnancy and childcare leads to hormonal changes, promoting bonding. Fathers' interactions with children boost their confidence and provide evolutionary advantages. Key idea number 5. The text discusses how emotions can affect communication and how they are processed differently in the male brain compared to the female brain. It implies that understanding these differences can help improve communication between genders. Testosterone affects neural development in male brains, emphasizing problem-solving over emotional communication. Male brains are wired to offer solutions when faced with emotional situations, which can lead to conflicts in male-female relationships. Biological differences in emotional memory centers can contribute to misunderstandings between partners. Gendered expressions and responses to emotions are influenced by hormonal differences. While male brains may show anger more readily due to testosterone, aging can lead to a more nuanced emotional expression. Key idea number 6. Summary. The text discusses the aging process of the male brain, focusing on changes in cognitive function, memory, and brain structure as men grow older. It touches on how these changes may impact overall brain health and emphasizes the importance of taking steps to maintain cognitive function and emotional well-being as men age. As men age, testosterone levels in their brains decrease, along with vasopressin, impacting relationships. The male brain becomes more like a postmenopausal female brain, leading to increased sensitivity, kindness, and emotional expression. This shift reduces defensiveness and anger, making men less prone to aggression and more focused on emotional connection. Loneliness can worsen with age if lacking close bonds, but staying connected to others benefits physical and mental health, prolonging life. In conclusion, male brains and bodies start developing at 8 weeks with a surge of testosterone. Testosterone, vasopressin, and prolactin shape male neural structures and biological drives throughout life, influencing his development from boyhood to potential fatherhood. In old age, decreased hormonal levels lead to bonding tendencies similar to postmenopausal females, promoting happiness and health. Thank you for listening to this summary. If you enjoyed this exploration, we invite you to discover other fascinating books on storyplanet.net. Don't wait any longer. A multitude of books, stories, and knowledge await you there. See you soon on storyplanet.net.